class now. Okay, right. So today we're going to cover a first topic on linear programming, and today we're going to concentrate on how to develop a model, how to transform a model for linear programming. So, let me see. My camera is not messed up. I like to record this one. Optimize, yeah. Control, stop sharing. Camera.
Mami, tinggal ni mah.
All right. So as I mentioned just now, we're going to start our new the first topic on engineering or production optimizations, and the first topic is linear programming. And for this particular class, we're going to look at the formulations of linear programming, meaning that how to develop a mathematical model to represent the situational and case studies, and then from there, then basically we're going to look at how to solve it. So for this lecture, we're going to concentrate on how to develop a model. So the outline for this particular topic, basically, we're going to look at the requirement of a linear programming problem. So if you want to solve a particular situation using linear programming, so if you want to optimize the situation or given situation using linear programming problem, using linear programming, that particular problem must have certain requirement. Only then we can use linear programming to solve it. And we're going to look at how to formulate linear programming models problem using an examples, shredded electronics. Right? So this basically what we're going to do today. So if you have any questions, just voice out. For some reason, I cannot see my chat. I tried to turn it on. I cannot see my chat. So you have to voice now if you want. If you have any questions. Right. Then what we're going to do is once we develop a model, so the plan is for next week lecture, which we have to find a replacement day. We're going to do graphical solutions to linear programming problems. So just now this week, we're going to look at how to develop a model, linear programming model, to represent the problem. And then after that, we have to optimize that model. So, we're going to cover that. We're supposed to cover that next week using graphical solution. Okay. So let's look at what's linear programming. So linear programming is basically a mathematical techniques. What it does is to help plan and make decisions relative to the trade-off necessary to allocate resources. So usually, if you have a situational problem, let's say, for example, if you're running manufacturing, right, manufacturing industry, and you want to optimize the profit of your operation, right? So what you can do is you can develop a mathematical model associated with the linear programming, and then you can use linear programming methods to solve to optimize your operation. So when you talk about optimize your operation, you can either maximize something or minimize something. So if your focus is on profit, then you want to maximize profit. If your focus in cost, then you can minimize cost. So linear programming is mathematical techniques to help plan and make decisions relative to the trade-off necessary to allocate resources. What it says is this: if you're in manufacturing industry, so to achieve, let's say, a target of certain profit level, you have limited resources that you can use to achieve that goal, right? So these linear programming techniques will actually assist you in making decisions how to best use your resources such that you can optimize your profit or minimize your cost. So that's what linear programming is all about. It's mathematical techniques that help you to make decisions on how to use your resources in order to meet your objective, whether maximize profit or minimize cost or whatever it is. Okay. And if you use this particular method, it will find the minimum or maximum value of the objective, meaning that when you want to optimize a particular problem using linear programming methods, you can either minimize or maximize something, as I mentioned just now. So if it's a profit, then you want to maximize your profit. If it's cost, then you want to minimize your cost, example, right? So it will find the minimum and maximum value of the objective. And it guarantees the optimal solutions to the model formulated. So it will guarantee that the solutions that you got using this linear programming method is the optimal solutions, meaning that once you come up with the linear programming model and you solve it with the linear programming methods, it will assist you on how to better utilize your resources to achieve your objective, either maximize something or minimize something. And that solutions is optimum solution. It's an optimum solution, right? Meaning that you cannot find any other better solutions than that based on the model that you develop. Okay. Any question so far? All right.
No, Doctor.
Okay, so and applications of linear programming, many, so I'm going to run down a list so so that you can have some ideas on how to apply this, where to apply these particular techniques, and you can apply these techniques in many situations. As long as you can develop mathematical model to represent the situation, and as long as it meets certain requirement, and as long as you want to minimize or maximize the objective functions or the goal. Okay? So in linear programming, some of the linear programming applications, one is, for example, if you want scheduling school buses to minimize total distance travel, meaning that if you have a company that has a bus services, you have many buses. Let's say, for example, you have 5 buses, right? And you have many customers, pickup locations, right? School buses. There are many students, and their houses are at different locations, and their schools also at different locations. So you want to make sure that you can schedule your pickup route, your buses pickup route, to minimize their total distance travel, right? Then you can actually use linear programming applications to do this. So it will tell you if you solve it using linear programming problem, you need linear programming methods. Then it tell you, bus A will pick up who and send to which school. Bus B will pick up who, which students, and then send to which school, so on and so forth. And that recommendation and that solution will be optimum, and it will actually minimize the total distance travel. So in that particular case, you can use this linear programming application. The other examples, the second example is allocating police patrol units to high crime areas in order to minimize response time. See, so the objective is to minimize the response time, meaning that if somebody called 911, then you can attend to that call at minimum amount of time. And so if you run a police department and you have patrol units, you have police car, let's say, for example, 5 police car, and you have to cover the area of, let's say, for example, Durian Tunggal, right? So you have to make decisions on where to position your police car, such that if you have an emergency call 911, then the police police patrol units can actually attend to that call at the minimum amount of time. So if you want to make that decisions, you can use linear programming application for that. The other applications, example of application is scheduling tellers at banks so that needs are met during each hour of the day while minimizing the total cost of labor. So this is a situation if you are a manager at a bank and you run the operations of that bank and you have to decide, how many tellers you need to open at given hours, because if you go to the bank, right, then basically number of tellers, number of windows, service window, sometimes varies at different time. The reason being because they have a history of at what time is a busy time, what time is not so busy time. So because of that, they can actually decide on how many tellers they want to open at what time, so that they can minimize the cost of labor. So if you want to look at how to schedule these tellers, meaning that how many tellers to be opened at what time, so on and so forth, you can actually use linear programming application to solve it. So it will actually give you a solutions on you should open, let's say, 5 tellers at 10 a.m. until 11 a.m. And then 10 tellers from 12 until 1 or until 2, right? So the solution will tell you how to schedule the tellers at the bank by hour or by day or whatever your desire now. Okay. So and the next applications, linear program applications, selecting a product mix in the factory to make best use of machine and labor hours available for maximizing firm's profit. So this is example. If you own a manufacturing facility, for example, a factory, and you have many product. Let's say you have let's say Proton. Let's say have 5 different cars model, right? And they want to decide, how many of each model should be built such that they can best use of the machine and labor to maximize their profit. So to make their decisions on how many units, how many volume of each product they should make to maximize their profit can be determined using linear programming methods. Okay. Next example is picking blends of raw materials in feed mills to produce finished feed combinations at minimum cost. So you can, so if you are, so usually feed mills refers to the operation to make animal food. Okay. So inside that animal food, basically it consists many ingredients. Sometimes corn, they mix it with wheat, mix it with rice, so on and so forth, such that the animal feed will contain certain percentage of protein, carbohydrate, so on and so forth, right? So if you want to decide how to pick how many percent of corn need to be mixed with how many percent of wheat need to be mixed with how many percent of rice, for example, to produce animal feed, then to minimize cost, then you can use linear programming application. It will tell you, how many, let's say, for example, how many kilos of wheat need to be blended with how many kilos of corn and how many kilos of rice, such that it meet the protein, carbohydrate requirement of animal feed, and you can do it at minimum cost. So basically, this can be solved using linear programming application. Okay. the other examples is example 6, determine the distribution systems that will minimize the total shipping cost. So if you're in the logistic industry and you have let's say, for example, you have many methods on how to distribute goods, and let's say, for example, this is a ship, a sea ship. And basically, if you can make decision, you can use the programming problem, the linear programming methods to make decisions. Which ship need to send which material to which destination, and it will minimize the total shipping cost. Okay. So if you look at these examples that's given just now, linear programming application is quite wide. You can use it in many areas as long as you want to optimize something. But however, there are few requirements that must be available in that particular situation for you to use linear programming application. Yeah. Any questions so far? No. All right. So let's look at the requirement of a linear programming problem. So these are basically the requirement. What need to be there for you to be able to execute and use linear programming methods to optimize a particular situation. Okay. The first one is basically the linear programming problem. The first one, linear programming problems seek to maximize or minimize some quantity. So that's the first requirement. First requirement is basically the goal for you is to maximize or minimize something, a quantity. And usually this is profit or cost, express and then objective functions. So first thing that you need to be able to do in linear programming, to develop a linear programming model, you need to come up with the objective function. And objective functions is an expression, is mathematical expression to maximize or minimize some quantity. And this quantity usually is profit or cost. Okay, but in example just now, right, you can also minimize distance travel. You can also minimize time taken, so on and so forth. So as long as you can come up with objective functions of that particular situation to maximize or minimize something, then you actually meet this particular requirement where you need to express the objective functions in the form of mathematical model. So that's first requirement. You need to be able to define what to be maximized or what to be minimized as objective function. So if it's profit, then it's optimized, then it's maximized. If it's cost, then you want to minimize. If it's distance travel, you want to minimize. If time taken, you want to minimize. If it's revenue, then you want to maximize. Okay. So that's first thing. The second thing, there must be a presence of restriction or constraint, limits the degree of which you can pursue your objective. So in a particular situation where you want to apply linear programming methods, there must be a constraints. There must exist a constraint. Example, if you're in manufacturing, then usually your constraint is number of equipment, number of operator, number of materials that you can actually utilize to make a product, right? If you have a situation where there is no constraint, right? Let's say, for example, you have limitless materials. You have limitless machines, you have limitless supply of operator. Then in that particular situations, that you cannot use linear programming problem to solve to maximize profit, because it doesn't make sense. It doesn't make sense, because if you have unlimited resources, right? If you have unlimited resources, then basically you can keep on producing parts and making more and more money, right? More and more profit. But that situation, I think, never or seldom exist in the real world. Yeah. So second requirement is there must be presence of restrictions or constraint that limits the degree you can pursue your objective. What's your objective? Objective is to maximize or minimize your objective functions, right? If it's cost, you want to maximize it. If it's cost, if it's profit, you want to maximize it. If it's cost, you want to minimize it. Right? And examples of constraint are in manufacturing operation, as I mentioned just now, it can be number of machines, number of materials, amount of materials, number of operators, so on and so forth. Okay. So this is two of the requirement for the linear programming problem. Okay. Any question? No? All right. Okay. That one, there must be alternative courses of action to choose from. Okay. So what this is, let's say, for example, if you in manufacturing, we'll talk about manufacturing because it's easier for you to imagine, I guess. In manufacturing, for example, Proton, right? They want to decide which model of car they want to make, such that they can better utilize their resources to maximize their profit. And Proton has few models. Let's say it has 5 models. So you have to decide, how many units of car you want to make for model A, how many units of car you want to make for model B, so on and so forth. So that actually the alternative course of action, because Proton can decide to build how many model A, how many model B, how many model C, in order to maximize the profit, right? But if Proton has only one car model, let's say, for example, Proton has only X50 model, no other models, right? Then basically Proton doesn't have alternative course of action to choose from, meaning that there's no choice. So you just make one model. So in that particular case, where there is no alternative courses of action to choose from, then you don't need to use linear programming problem to optimize your operation, maximize profit, because it's given already. You don't have another options. Just build X50 model. Right? Another examples, maybe if you are in the farming business, you want to decide, whether you want how many acres of land you want to plant with watermelon, how many acres of land you want to plant with corn, so on and so forth, right? So that basically represent the alternative courses of actions to choose from for agriculture sector, right? But if the only option that the farmer has is to plant, let's say, for example, watermelon, only watermelon, then basically there is no alternative course of actions. And for that particular case, we don't have to use linear programming problem to optimize it, right? So that's the first one. So the first one just now, there must be, we have to be able to define the objective functions, either to minimize or maximize something. If it's profit, you want to maximize it. If it's cost, you want to minimize it, for example. Second requirement just now is there must be a constraint. There must be a constraint. And the third requirement here, there must be alternative courses of action to choose from. Okay, and the fourth one, the objective and the constraint in linear programming problem must be expressed in terms of linear equations or inequality. And the fourth requirement is you must be able to define to come up with mathematical expression in linear form, right? To represent the objective functions, meaning that objective function is, let's say, profit, to maximize profit. So you should be able to come up with an equation on how to calculate profit, okay, in linear form, and also how to define the constraint in mathematical form. For example, manpower, number of machines. So you must be able to define mathematical expressions on machine utilization, for example, right, in linear form, in linear equation or inequalities. So linear means what? Linear means there is no quadratic form, so on and so forth, right? So in your equations, in your mathematical modeling that you're going to develop, all the variables must be linear, meaning that so if y equals to x square, this is quadratic, this is not linear, so this is not acceptable. So if y equals to, let's say, for example, x plus 2 x, y equals to x1 plus 2x2, then this is considered as linear form, right? Linear form. And so you should be able to express the objective functions, the objective and also the constraint in mathematical form. It must be linear, equations or inequality. So you must be able to express it in terms of equation. So equation is this. Inequality is you have a symbol of greater than or equals to or less than or equals to. Right. So basically, you have to develop a linear programming model to express the objective functions to maximize something or minimize something, subject to the constraint for that particular situations in form of linear equations and also or linear inequalities. So basically, those are the 4 requirements that must exist before you can proceed and use linear programming methods to solve a particular problem. So first one, you should be able to express the objective functions. So objective function is to maximize something or minimize something. Second, you must be able to express mathematically, there must be presence of constraint. So for example, a number of machine, so on and so forth, right? And the third requirement is there must be alternative course of action to choose from. So if the company has only one option to choose from, examples given just now is in the manufacturing of a Proton, manufacturing of car by Proton. So if there is if Proton has only one model, then there's no alternative course of actions. Then you don't use linear programming problem to solve it, to optimize it. Right? And the last one, you must be able to express the objective functions and the constraint in mathematical model, and the mathematical model must be linear, and it can be an equations or inequalities. So those are the 4 requirements for you to be able to use linear programming problem to solve it, to optimize the situation or the problem. Any questions?
Any questions? No hand.
No? All right.
No.
Okay, let's look at examples. We're going to look at on how to develop a linear programming problem. So this is for formulating linear programming problem in terms of mathematical model. And for this, we're going to use examples of product mix problem at this company, electronics company called Shader Electronics. And this company, Schneider Electronics, they make two products. One is Walkman, and the other one is Watch TV. Okay? And what they want to do is they want to determine the mix of product that will produce the maximum profit. Right? So this company, Schneider Electronics, basically it has two products. One is Walkman, the other one is Watch TV. And what they want to do is they want to determine the mixed product, meaning that how many Walkman to be produced, how many Watch TV to be produced, such that they maximize the profit. Yeah. And it's given that this data is given. So the given data is basically you have hour required to produce one unit for Walkman and Watch TV. And this is basically the resources. So the resources is basically they have electronics department. So this is the man hour in the electronics department. They have assembly department. This is man hour of assembly department. And in the electronics department, basically they have available hours for this week is only 240. That's all. And in assembly department, the available hours to be utilized is only 100 hours. Okay, so those are the constraint. Those are the constraint. And for each Walkman, right, it requires 4 hours of electronic department time and 2 hours of assembly department time to produce a Walkman. So if I want to make one Walkman, it need 4 hours of electronics department time and 2 hours of assembly time to make one Walkman. Yeah. For Watch TV, it requires different amount of resources. It requires 3 hours of electronics time and 1 hour of assembly time to produce one Watch TV. Right? And each Walkman, if you make one Walkman, your profit is $7. And if you make one Watch TV, your profit is $5. Okay. So what you need to do is basically you need to develop a linear programming model for this particular situation. Yeah. So first step that you need to do in any given problem, linear problem, you have to come up with the decision variables. You have to decide what are the decision variables. Decision variables is basically the decision that you have to make at the end of the day. And for this particular case, it's stated, right? It's stated that the company wants to determine the mix of product that will produce the maximum profit, meaning that it indicates that what they're trying to do is they want to make decisions, know how many Walkman they're going to make, how many Watch TV they want to make. So it's clearly then the decision variables for this is the Walkman and the Watch TV, right? So the decision variable would be how many numbers of Walkman they want to make and how many Watch TV they want to make. So these are the decision variables. So for any given linear programming situation, first thing you need to do is come up with the decision variables. And for this case is the first one is number of Walkman to be produced, which is X1. And X2 is number of Watch TV to be produced, X2. So whenever you said X1 is number of Walkman to be produced, X2 is number of Watch TV to be produced. So this is what you need to decide first. What are the decision variables? right? And this x1 and x2, you can use any variables. I can just use y1, y2, or I can use x, I can use y. You just have to be consistent. You just have to be consistent, right? So for this particular case, x1 is number of Walkman to be produced, and x2 is number of watch TV to be produced. So that's first thing you need to do, right? Second step, what you need to do is you need to come up with objective function. Objective functions. So again, if you remember when we discussed about the requirement just now, the requirement is you should be able to express the objective of your optimizations. And for this particular case, it's stated very clearly. What they want to do is they want to maximize the profit. They want maximum profit. So because of that, the objective function is maximize the profit. So once you decide what is the objective function, which is maximize the profit, you should be able to define the calculations of the profit based on the decision variables. Right? So just now, basically, we have decided that the decision variable is x1 and x2, and x1 represent Walkman and x2 represent Watch TV. So objective function is basically a mathematical equations to calculate the profit. And for this particular case, it's given that for every single Walkman that you're going to make $7 profit. Every single Watch TV you make, you're going to make $5 in profit. So I can calculate profit equals to 7x1 plus 5x2. And this is your objective function. This is your objective functions. So the stated objective function is basically maximize profit. And I can calculate that profit equals to 7x1 plus 5x2. Okay. Any questions?
No, sir.
Boleh?
Boleh.
All right. And when you talk about once you develop these objective functions, right? The next step is you have to define the constraint. Right? So remember, there must exist one of the requirement for linear programming problem is basically there must exist a constraint. Okay. So the constraint can be defined. Basically, there are three type of constraint that can be defined. It can be upper limit where amount used is less or equals to, lower limit where the amount used is greater than equals to, and equalities where the amount used equal to the amount of resources. So in this particular case, right? If you look at this, now what are the constraints? What are the constraints? Anybody? Guys? In this particular case, what are the constraints?
Available hours?
Yes, available hours for electronics and assembly. So the constraint for this particular case is electronics and assembly, right? So once you identify the constraint, right, you need to express this constraint in mathematical form. So, and mathematical form based on the decision variables that you have chosen just now. So in this particular case, so in this particular case, there are two constraints. One is electronics, and the second one is assembly. So the first constraint, let's look at the first constraint. So the first constraint will be electronics. So for the electronics, I can write the constraint is for every Walkman need 4 hours. right?
Jadi
So
15 minit
electric
berapa?
constraint, then the electric department constraint is 4x1, right? So every x1 which is Walkman, it requires 4 hours of time, right? And for every watch TV, for electronics, for every watch TV, then it requires 3 hours. So it's 3x2,
Dah,
right?
15 minit.
So if I plug in x1 and x2, then I know the total amount of time that I'm using for electronics assembly.
Kecil
Okay. And this value for x1 plus 3x2 cannot exceed 240 hours because that's the available hours this week. Can it be less? Yes, it can be less, but it cannot be more, right? So because of that, I'm going to use the inequality less or equals to 240. Okay? So that's the first constraint. So electrical time, electrical department time. To calculate the utilizations of electrical department time is basically 4x1 plus 3x2, because every single x1 which is Walkman I'm going to utilize 4 hours. For every single watch TV I'm going to utilize 3 hours of electronics time. So I can calculate the amount of time utilized time for the electronics assembly is 4x1 plus 3x2, and this value amount of time cannot exceed 240. So it must be less or equals than 240. So that's basically my first constraint. Okay. Any question? All right. And the second constraint is assembly. And for the assembly, I can calculate the assembly time used to make Walkman and watch TV is equals to 2x1 plus 1x2. And this amount of time, 2x1 plus 1x2, must be less or equals to 100. Right? So basically in here, then we know that the constraint can be defined, and there are two constraints. The first constraint is electrical time. The second constraint is assembly time. For the electrical time, the equation to calculate the electrical time is 4x1 plus 3x2, and this is must less than equals to 240 because that's the limit. Okay? And for the assembly time, basically I can calculate the amount of assembly time used is equals to 2x1 plus 1x2. So depending on number of x1, which is Walkman I make, then I can calculate this assembly time, right? But the assembly time, the total assembly time must be less or equals to 100. Any questions? Okay, so basically then these are the constraints that I mentioned just now. For the first constraint is that drink time use is 4x1 plus 3x2 must be less than 240. Second constraint is 2x1 plus x2 must be less equals to 100. For this is for the assembly time. Yeah. So then your mathematical the complete linear programming model that has been developed just now is basically, so you have decision variable equals to x1, and so this is x1 is Walkman, and x2 is watch TV. Okay, that's decision variables TV. That's your decision variables. Okay. And then the objective functions is just now is equals to maximize profit, and that profit is equals to 7x1 plus
Kecil ni.
5x2. Right? Subject to constraint, and there are two constraints, and the constraint is for electrical, for electronics is 4x1 plus 3x2 must be less equals to 240, and assembly constraint 2x1 plus x2 must be less equals to 100. Right? So this is basically the complete linear programming model. And if you look at all the equations, they're all linear. They're all linear. Right? So you have objective functions, you have decision variable x1 and x2. Objective functions is maximize profit, and that equals to 7x1 plus 5x2. Subject to the constraint, and the constraint are the electrical time, which is 4x1 plus 3x2 must be less or equals to 240. And the assembly time is 2x1 plus x2 must be less or equals to 200. Right? And there are two other constraints, and there's one other constraint, which is basically x1 and x2 must be greater or equals to 0. Right? So meaning that x1 and x2, there must be a value for x1 and x2 which is greater than 0. Equals to 0, equals or greater than 0. It can be 0, it can be 1, 2, 3, and so on and so forth. But it cannot be a negative number, because it doesn't make sense to have x1 equals to -1, because x1 represents number of Walkman, right? So you cannot have number of men equals to -1. So because of that, we have to put a constraint. Now the constraint for all the variables here, which is x1 and x2, must be greater or equals to 0. So this is the complete linear programming model for that particular situation, where you define the decision variable, which is x1 and x2, define objective functions, maximize profit equals to 7x1 plus 5x2, subject to constraint. The constraint are electrical time, which is electronics time, which is 4x1 plus 3x2 must be less than equals to 240, and assembly time equals can be calculated by 2x1 plus x2 must be less or equals to 100, and x1 and x2 must be greater or equals to 0. So these are the complete linear programming model. Okay. Any questions? No? All right. Okay, so this is another examples of linear programming applications. It's a production mix examples again. So you have a product. There are 4 products. So to do it, 4 product. The name of the product is XJ201, so on and so forth, right? And each and every single of them has to go through 1, 2, 3, 4 departments, right, to make one product. But the time taken for each product at different department, wiring, assembly, different operation, wiring operation, drilling operation, assembly operation, special operation, the amount is different. The amount of time is different. Okay. And each of the product has different profit, Okay. And it's also given that for each department, wiring, drilling, assembly, so on and so forth, there is a capacity in hours. And for the product, there's also a minimum production level that need to be met. Okay. So based on this, then you have to come up with a linear programming model, right? So to come up with a linear programming model, the first decision that you have to make is what? To define what? Decision variables. What are the decision variables in here? Anybody? What do you have to decide in here?
Insert pula.
Anybody? By the way, this particular topic is very important because if you don't know how to develop a model, then basically you won't be able to solve anything. So the first thing that you need to do in linear programming, be able to develop a mathematical model. So let's say, for example, in exam, if you're asked questions to solve linear programming problem, first thing that you need to be able to is develop a model. If you cannot develop a model, then basically there's no marks for the subsequent steps, right? So my question is, so for this particular situation, what are the decision variables? What do you have to decide? This is production mix example. Anybody?
Saya tak buka ni. Yalah, jom. Tadi aku nampak ada budak tu. Dah tak buka juga dah.
Number of products to be produced.
Correct. Number of products you produce. So decision variable will be this. XJ, how many units of XJ201 you want to make? How many units of XM8 you want to make? How many units of TR you want to make? How many units of BR you want to make, right? So I can assign it to be X1, X2, X3, and X4. So my decision variable would be X1, X2, X3, and X4. And X1 is number of units for XJ201. X2 is number of units for XM, so on and so forth, right? So that's the first thing, decision variables. How about my objective functions? So decision variable is done. What is objective function?
Capacity now.
You want to maximize or minimize?
Maximize.
So if you look at this, this will give you a clue. So it gives you a unit profit, meaning that for every single unit that you make for X1, X2, X3, X4, these are the profit. So objective function is what? Or minimize?
Maximize profit.
Right. So maximize profit. And how to calculate the profit? So it's here, it shows that every X1 unit that you make $9. Every X2, you make $12. Every X3, you make 15. Every X4, you make 11. So I can calculate the profit equals to 9 X1 plus 12 X2 plus 15 X3 plus 11 X4. So that's my objective function, right? That's my objective functions. So I have decision variables defined. I have objective functions defined. Maximize profit equals to 9x1 plus 12x2 plus 15x3 plus 11x4. Subject to constraint. So I need to define my constraint now. So I'm going to maximize profit subject to this constraint. That's why it says subject to something, subject to constraint. What are my constraints? Anybody?
Minimum production.
Pardon me? Minimum production.
Yes.
Okay, so so I have a production level, right? So minimum production. How do I define that in equation, in mathematical form? So I can do that like this. Minimum production for X1. Okay, minimum for X1 is basically X1. So minimum production level for X1 is what? 150. So it must be greater or equals to 150. And second constraint is minimum production for X2. And X2 must be greater or equals to 100 X3 must be greater or equals to 300, and X4 must be greater or equals to 400. So that's the first four set of constraint where it talk about the minimum production level. X1 must be greater or equals to 150, X2 must be greater or equals to 100, so on and so forth. What are the constraints?
Assembly. Capacity.
Anybody? What are the constraints are there?
Capacity in hour. Output in hour.
Kakak cepatlah buat.
How about this process? Wiring, drilling, assembly, and inspection, right?
Oh.
So for wiring, if you look at this, for department wiring, capacity is 100 and 1,500, right? Drilling, there's capacity. So basically, there's also a constraint in terms of capacity. So first, I have a capacity of wiring constraint, and I can define that basically by this equation. I can calculate the capacity utilizations of wiring. So because it shows here for X1, it requires 0.5 hours, X2 requires 1.5 hours, X3 requires 1.5 hours, X4 requires 1 hour. So capacity for wiring, which I can calculate the wiring utilization as 0.5 X1 plus 1.5 X2 plus 1.5 X3 plus 1 X4. And this is the capacity for wiring is 1,500. So what signage should I use? Equals to, greater or less, or more? Greater or equals, or more equals? What signage should I use here?
Satu lagi satu.
Anybody?
Less.
So it must be less or equals to 1,005, right? And I can do the same thing for a drilling. And this is 3x1 plus 1x2 plus 2x3 plus 3x4 must be less or equals to 2,350. And assembly, same thing, and inspection, same thing, right? So I can do it for assembly and then inspection. Any other constraint other than this?
That's all.
That's all. The other constraint is X1, X2, X3, X4 must be greater or equals to 0. Any question? No?
Online jawab.
Right. So basically, the solutions you can. So this is the solutions of it. So basically, this is the whole thing. So this is the decision variables. This is the objective function, and this is the constraint. Right. And one thing that they're written in here: x1, x2, x3, x4 must be greater or equals to 0. So this is called linear programming model. Linear programming model for the particular situations. So you express the objective functions, the decision variables, express the objective function, which is maximize profit, subject to constraint. These are the constraint, and all these constraints and objective functions defined using linear, is defined linearly. Right? Any questions?
Oh.
Okay. All right. Okay, so I'm going to show you stop
Baru.
sharing. So we need to do few.
Apa tu?
Okay, share.
Oh,
Okay, can you see this?
sekejap.
Can.
Okay. So let's do this. So I'm going to give you let's look at the first problem. Two mines company problem. So read it. I give you maybe 5 minutes, right? Come up with the linear programming model, and basically we're going to discuss. I'll give you, let's say, 3 minutes. 3 minutes. Right? So look at it, read it, understand it. I give you 3 minutes. Come up with the decision variables, objective function, and constraint. And in 3 minutes, you're going to discuss. Right?
Go. Soalan ni tadi terpadam. Mesti two mines company on two different mindset products which are being crushed is scattered into three clusters. Like medium and low grade, the company has contracted to provide a smelting plant 24 per week. Dia lagi pandang jam dia tu. Ada orang yang soalan aku ni doktor. Aduh, tak faham apa. Aduh, ya. Tekan.
All right. Okay, so what are the decision variables for this? Anybody?
Type of mines company.
Pardon? So what's decision variables?
Mana pola tinggi?
Right, using this.
Ini kan tahun.
So what are decision variables?
Tebal macam ini pula. Pandai lah. Orangnya tahu sedap kan.
Just now somebody say something.
Enggak ada, dia pakai pun. Dia dah tak payah nak jadi duit.
Mine X, mine Y, Doktor.
Okay, mine X and mine Y. So decision variables would be so I can say x1 equals to mine X and x2 equals to mine Y. What's the unit when you say that x1 equals to 1, what does it mean? X2 equals to 1, what does it mean? What's the unit? So just now you said that x1 is mine X, x2 is mine Y. But what does it mean? Just now, for example, x1 and x2, examples that we did just now, electronic shredder, right? X1 is number of watch TV you make. X2 is number of X1 is number of Walkman you make. X2 is number of watch TV you make, right? So for this particular case, x1 is equals to mine X. But what does it mean, mine X? What about mine X?
The name.
Anybody?
The name of product. Aduh.
How many days should each mine be operated?
Correct. So basically, if you look at this statement, develop linear program model to determine how many days per week should each mine operated to fulfill the smelting plant contract. So this is the decision that you want to make, right? So basically, the unit for this is number of days of operation. Number of days, right? So if the solution is x1 equals to 2, then it says that mine X should operate 2 days a week, right? If x2 equals to 0, meaning that indicates that mine Y should not operate any days a week, right? So when you come up with decision variables, it's very important to have a unit to that decision variables. For this particular case, is number of days of operation per week. Okay, it's good. So we know what's the decision variables is x1 and x2. X1 is number of days mine X to operate. Number of x2 is the number of days mine Y operates, right? So that's basically the decision variables. What's the objective functions? What's objective functions? Anybody?
Cost per day. Bukan. Production.
What's objective functions for this?
Tak tahu lah, Doktor.
I don't have your names to call.
Aku tak panggil lah. Aku tak buka suara, takut. Dalam lain jawab.
So what's objective functions? Anybody? Is it to maximize or minimize?
Minimize cost.
Minimize, because it's given cost. So if it's given cost, it must be minimize cost. And cost is equals to, how do you calculate cost? How do I calculate these objective functions?
180 x1 minus 150 x2.
Should it be minus or plus?
Oh.
Plus.
Plus, right? Because you want to calculate the cost. So if I ask you what's the cost of this operation, the cost would be 180 x1, because cost per day is 180. X1 is number of days of operation, right, for x1. So should be 180 x1 plus, not minus, because you just want to calculate cost, right? Plus what? 160
X2.
x2. So if I define what's x1 and x2, I can actually calculate the cost, which is 180 times x1, which is number of days x1 mine y operate, mine x operate, plus 160 times x2, which is number of mine y operate, right? So this is objective functions. Good. And then subject to constraint. What are the constraints?
Production dia. High, minimum, low.
Anybody?
Jawablah cepat. Saya tak jawab.
Anybody?
Constraint to
What are the constraints?
production.
So it's here, the two mines company own two different mines that produce ore, which after being crushed is graded into three classes: high, medium, and low grade. The company has contracted to provide a smelting plant with 12 tons of high grade, 8 tons of medium grade, and 24 tons of low grade ore per week. The two mines have different operating characteristics as detailed before. Detailed below, right? So what are the constraints?
Production punya tu. Tahu tu. Medium, low grade tu.
So one of the constraint is basically they have to supply a smelting plant.
Per week.
Yeah, for high grade, medium grade, and low grade ore, right? They're committed already, right? So subject to constraint, the first constraint is supply of high grade ore, and I can define that high grade ore with what? 6x1, because if high grade, right? For mine x1, they can produce 6 tons a day, right? For mine y, it can produce 1 ton a day only. So supply high grade ore where the numbers of number of tonnage of high grade ore can be calculated with 6x1 plus 1x2, right? And this high grade, what is the constraint for the high grade? Is 12 tons, right? So they have promised a smelting company, right? They're going to deliver 12 tons of high grade ore, right? So the signage should be equals to, less or equals to, greater or equals to 12 tons.
Less.
Less. If it's less, then this smelting company will be mad at them, mad at the mining company, right? Because if it's less, meaning that we can say that this we're going to produce, we promise them they're going to supply them 12 tons. If you say here less than, then you're saying that you can produce, let's say 10 tons. If you produce 10 tons, but you promise them you're going to supply 12 tons, no, would you be in trouble? Yes, right? So it should be what?
More.
Yeah, it should be greater to than equals. So these numbers are going to provide a smelting plant with 12 tons. So it's either equals to or greater than, right? But at least I'm going to supply them 12 tons.
Oh.
Okay. And second constraint, then basically for the supply of medium grade, and I can define that as 3x1 plus x2 and greater than equals to 8 medium mean. And the other one is low grade. Low grade is equals to 4x1 plus 6x2 must be greater equals to 24. Okay, so we have this constraint. What are the constraints?
Medium grade.
What are the constraint? The other constraint is x1, x2 must be greater equals to
Oh,
0. Okay. Any questions?
no.
No.
All right. So let's look at the second examples. Production planning. This one. I give you again 3 minutes to read and work through and we have to discuss. 3 minutes.
Sebab selit. Company manufacture 4 variants of the same product in final part of manufacturing process. The example. Dewi tadi apa? Apa tah? Prof. S1, S2, S3, S4. Given the current state of labor force, the company estimates that each year they have 100,000 units of assembly time.
Mak, nampak suji tak? Suji tak pakai tepung jagung tapi. Mak, suji ni tak pakai tepung jagung.
Okay, let's look at this. Again, what are decision variables?
Decision variable.
Tak lah, bukan dia buat gaul-gaul apa bahasa.
Anybody?
Product variance.
So for that variance, so I can say that the decision variables would be x1 for variant 1, x2 variant 2, x3 variant 3, x4 variant 4. What's objective function? Maximize or minimize?
Maximize.
So maximize profit, right? So I can calculate profit by calculating, so profit is given in here, right? So 1.5 x1 plus 2.5 x2 plus 3 x4 plus 4.5 x3 subject to constraint. What are the constraint?
Sebab cost nak kurangkan, mesti nak benda sikit. Kalau profit mesti nak banyak maximum.
Assembly, English,
Yeah.
pack.
So subject constraint, first one is assembly, right? So assembly is basically 2x1 plus 4x2 plus 3x3 plus 7x4, and it must be what? They have only 10,000, 100,000 minutes of assembly time. So this will be
Less than or equal.
less than or equals to 100K, right? So same with a polish and packing, right? So so basically, and then x1, x2, and x3 greater than 0. So this is quite straightforward. Let's look at this. Can I see in one page? Yeah, can. Okay, let's look at this particular problem, canning company problem. A bit more involved. So I give you 5 minutes for this one. 5 minutes.
Apa ni? Buat kau plan decision making. Pumat depan sini kan? Depan sini kan? Sejuk lah pula. Ngantuk ah. Sini dia value bukan terus sebut macam mana. Objective. Function. Truth function. Jadi function dia. Minimize. Minimize cost.
All right. Can you hear me?
Yes, Doctor.
Okay. So do you need more time, or we can discuss now? Guys, do you need more time to read this through, or you want to discuss now?
Can discuss.
Anybody?
We can discuss now, Doctor.
Okay. What's decision variables?
From 10.
What does
S1, S2, S3.
Plan A, Plan B.
Okay, so it says here, so some of you say that S1, S2, S3. Some of you say that plan A, plan B. So let's look at this. Yeah? So this is a canning company, operates 2 canning plants. So this canning company ada 2 canning plants lah, ada 2 factory. Factory A and factory B, plant A and plant B, right? The growers are willing to supply fresh fruit to the following amount. So there's a farmer, a grower, that actually willing to supply fresh fruit to this canning company. And there are 3 of them, 3 growers, S1, S2, S3. So supplier 1, supplier 2, supplier 3. This supplier 1 can provide 200 tons of fresh fruit at $11 per ton. Supplier 2, 310 tons at $10 per ton. supplier 3, 420 tons at $9 per ton, right? And since these two plants at different locations, and these these farmers that want to supply fresh fruits at different location, then the shipping cost from each supplier to the plant will be different. So the shipping costs are given here. These are the shipping costs given here, right? So from S1 to plant A is $3 per ton. S2 to plant A is $2 and $3 from S3. So for plant B, from S1 is 3.5, S2 is 2.5, and 4 plant B, right? And this plant, these two plant, plant A and plant B, has different capacity, meaning that the amount of the amount of fresh fruit they can process are different. So for capacity for plant A is 460, plant B is 560. And since they're at two different locations, the labor costs are different also. So maybe one in Kuala Lumpur, one in Malacca, right? So labor costs will be different. So maybe the Kuala Lumpur one is going to be higher. So labor cost for plant A is $26, and for plant B is 21, right? And the canned fruits are sold at $50 per ton to the distributor. Once you can it, right, you can sell it to a distributor, and the price that you can sell is $50 per ton, assuming that all the fresh fruit are turned into canned fruits, right? And the company can sell at this price all they can produce. So there's no limit. The company can make as many as they want, right? And they can sell it to the distributor at $50 per ton, right? The objective is to find the best mixture of quantities, okay, supplied by the tree growers to the two plants, so that the company maximize its profit. So what do you have to decide? Again, read this. The objective is to find best mixture of quantities supplied by tree growers to the two plants, so that the company maximize its profit. So what decisions that you have to make?
Oh, manja.
Anybody? It's stated here.
Quantity supply.
What? Quantity supplied.
Yeah.
So quantity supplied by whom? So again, read the objective clearly, carefully. The objective is to find the best mixture of quantity supplied by the tree growers to the two plant. So what does it mean?
Kombinasi mana yang bagus untuk tiga?
So it means that you have to decide, right? Supplier 1 will supply plant A how many tons? Supplier 1 will supply to plant B how many tons? Supplier 2 will supply to plant A how many tons? Supplier 2 will supply plant B how many tons? And supplier 3 will have to supply plant A how many tons and plant B how many tons. That's what you have to decide. So basically, to find the best mixture of quantities supplied by the tree growers to the two plants, so that company maximizes profit. So how many decision variables do I have?
3. 3.
3.
3. So because is 6. 6. So basically so my decision variable will be like this. So I have plant A, plant B, supply 1, supply 2, supply 3. Okay. So I have to decide how many tons supplier 1 will supply to plant A and plant B. How many tons supplier 2 will have to supply to plant A, plant B? How many tons supplier 3 supply to plant A, plant B? So my decision variable will be X11, X12, X21, X22, X31, X32. So I have 6 decision variables to decide, right? I have 6 decision variables to decide, right? So when I say that X11, what does it mean?
Dekat yang
If
pertama.
I say that X11 equals to 1, what does it mean?
Supplier 1 to plant A.
Right. So supplier 1 will supply 1 ton of fresh fruit to plant A. Right. If I say that X22 equals to 10, then it says that supplier 2 will supply 10 tons to plant B, so on and so forth. Any questions?
No.
No.
Right. So what's my objective function?
Maximize profit.
So my objective function is maximize profit. So how do I calculate how do I calculate my profit? How do I calculate profit?
Total revenue minus total cost.
Right. So revenue minus cost. So what's revenue?
Total revenue
So
apa?
how do I calculate revenue? Anybody? How do I calculate revenue? Dah ambil engineering mathematics lah?
Huh?
Engineering, no, apa ni? Economics engineering economics Dah ambil kan? So macam mana calculate revenue? Macam mana saya nak calculate revenue? So now your objective functions consists of 2 parts lah. Satu revenue, satu cost. So you have to define revenue and you have to define cost. So my revenue, so this is still objective functions. Revenue equals to what? So if you read here, the canned fruits are sold at $50 per ton to the distributor. Company can sell at this price all they can produce. So basically, revenue for this particular situation is $50 per ton, right? Times whatever number of tons they can produce, right? So how do I calculate revenue?
50 times 460.
Why 360?
460.
Why 460?
Because plan A can have the capacity of 460.
But that's the capacity, right? That's the capacity. But how many actually will be produced? How many tons will be produced? How many tons will be produced? Look at the addition variables, right? X1, if X11, then basically I ship if they say X11 is equals to 1, I ship 1 ton from S1 to plant A, right? So if X12 is equals to 10, I've shipped 10 tons from supplier 1 to plant B. All this shipment of 10 tons, 1 ton, so on and so forth will be converted into canned fruits. So the number of tons of canned fruits I'm going to make is basically x11 plus x12 plus x21 plus x22 plus x31 plus x32. Right? Make sense?
Makes sense.
Does it make sense?
Yes, Doctor.
Okay, so
That's
revenue
correct.
is equals to 50 times x11 plus x12 plus x21 plus x22 plus x31 plus x32. That's my revenue. All right. Any questions?
No, Doctor.
So what's cost? So what's cost? Sorry, I hate online class. Don't know where to write cost. What are the cost? What kind of cost do we have in here?
Labor cost.
Shipping and labor costs.
So let's say shipping cost. So the first cost is shipping cost. Right? So how do I calculate shipping cost? So if I ship from S1 to plant A, it's $3 per ton. If I ship from plant S1 to plant B, it's 3.5 per tons, right? So how many number of tons I make? How many number of tons I ship from S1 to plant A? X11, right? How many tons I ship from S1 to plant B? X12. I don't know what, but it's X12, right? Understand? So my shipping cost basically is 3x11 plus 3.5 x12 plus 2x21 plus 2.5 x12 plus 6x31 plus 4x32. So I have shipping cost. I define as such. Right? And what are the costs?
Labor.
Labor costs. I have labor costs. So how do I calculate labor costs? So given here, labor cost per ton for plant A is 26,
26.
right? So how do I calculate a labor cost for plant A? 26.
X11 plus X21 plus X31.
Correct. So you got it now. X11 plus X21 plus X31 plus for plant B is 21 X12 plus X22 plus X32. That's labor cost. What are the costs?
No.
Road costs.
What? Somebody mentioned
Fruits
just now?
cost, Doctor.
Fruit cost. Yeah, fruit cost. So fruit cost, right? So S1 is 11 tons, $11 per ton. S2, $10 per ton. S3, $9 per ton. So fruit cost is equals to, so for S1 is 11 tons. So how many S1 will ship?
Two.
X11
X12.
plus X12. So plus 10 times for plant 2 is x21 plus x22 plus plan 3 is 9, x31 plus x32, right? Okay. Any other cost? That's
No.
all right. That's all right. So your objective function become long, right? It's revenue, which is these functions, 50
Apa?
times x11 plus x12 plus x21 plus x22 plus x31 plus x32,
Sekejap lah, aku tengah
right?
silent ni.
Minus cost. What are the costs? All these shipping costs, labor costs, and fruit costs. So you get profit. Okay. Any questions?
No, Doctor.
And then constraints, subject to constraint. What are the constraints?
Supply.
Which supply? S1, S2, S3, right? So because it says here, they're willing to supply for S1 is 200 tons, S2 is 310 tons, S3 is 420 tons. So satu adalah the fresh fruit supply constraint, right? For this one is for S1. So X1 supply is actually X11 plus X12, right? So what's the is it greater than or equals to or less than equals to or equals to?
Less than
Okay.
and
So
equals to.
for this particular case, it's quite ambiguous, right? It doesn't say that at least or not more than, right? So, but usually, so when this fresh fruit supplier, fresh fruit, with a vendor promise you to supply materials to you, right? The promise is at least they're going to supply at that particular quantity, right? Because if you let's say promise 200 tons and all of a sudden you can only ship 100 tons, your company in trouble, right? Because then my canning plant cannot operate, right? So because of that, the assumptions that you can make, this is the minimum number they can supply. So it should be greater to or equals to 200. If in exam, then it will state clearly lah, is at least or great or not
Sarjan
more
tak ada
than,
exam lah.
right? For this particular case, then basically you can assume
Tahu
that
test biasa kot.
this is at least 200 tons or more. And then for S2, we have X21 plus X22 greater than 310. And then we have S3, 31 plus X32 greater than 420. Right? What are the constraints?
Banyak betul constraint dia.
Plant capacity.
Yeah, plant capacity. So we have constraint with regards to the plant capacity. And then we have plant capacity B constraint. So plant capacity A would be X11 plus X21 plus X31, right? Must be less or equals, the capacity is only 460, right? And for capacity for plant B is X12 plus X22
Apalah.
plus X32 must be less or
Kenapa
equals
aku
to
silent ni?
560, right? Any other constraint? Any other constraint? Nope.
Hah?
Any other constraint?
No.
The other constraint is basically xij,
Oh,
right? x11, x12, x21, x22, so on and so forth must be greater or equals to 0. That's the last constraint. Okay. So basically, this is examples of problem in for the canning companies, canning company manufacturers. Then you have multiple suppliers and multiple plant, and you have to decide, how many to ship from one supplier to one plant to maximize profit. Okay. And for these examples, you can see the objective functions become quite lengthy, and the decision variables is actually in a matrix form. Right. Any questions? Okay. So what I want you to do next, because we are out of time, I have class at 10. So we have our time. So what I want you to do for Friday, this Friday, we have class Friday, right? So look at this factory planning problem, this one, and the other problem is factory planning problem, and also this the other problem is Ozark Farms problem. These two problems, right? Look at it, and basically we're going to solve. We're going to develop the what do you call it? The linear programming model problem, right? So again, look at this factory planning problem and this special fit mixture problem, and then go through it. And on Friday, we're going to discuss. Okay. Any questions?
no, doctor.
No, doctor.
All right. So if no questions, then I'll see you guys on Friday. What time is Friday? Our class?
Tak ingat, doctor.
Anybody?
At 3.
At 3.
3. Yeah.
So I'll see you guys at 3 on Friday then. I'll send you the link before the class. Okay, so no questions, then basically that's all for today. I'll see you on Friday. Thanks. Assalamualaikum.
Waalaikumsalam.
Thank you, doctor.
Thank you.
Kejap. Sekejap, plan A, plan B.
Kita tunggu 12. Oh iya. Dia tak ada untuk mengambil.